In this video, let's talk on error analysis in measurements and least count. You can take your jotter and jot points here. So in the previous video, we have discussed measurements. We said before you can take any measurements, your aim is to get the size or length or magnitude of something. That means I can say measurement is the determination of the length or size or magnitude of something. And measurement is an important aspect of physics because whenever we want to know about a physical quantity, we take its measurements first. What are these physical quantities? Physical quantities are those quantities that can be measured by an instrument and by means of which we can describe the laws of physics. Examples of physical quantities are length, mass, temperature, volume, density, force, momentum, weight, etc. And instruments used in measurement are called measuring instruments. Now, you can watch my video on measurement again to get other points. Now, we can have error. We can have error. Then what is error in measurement? The measured value of a physical quantity is usually different from its true value. So the result of every measurement by any measuring instrument is an approximate number which contains some uncertainty. So now this uncertainty is called error. And every calculated quantity which is based on measured values also has an error. Now, what are various causes of error in measurement? Now, let us talk about least counts first. That is least count error. So I will use a ruler to illustrate least count error. So let's say we have a ruler. Yeah. So let's say we have a ruler and I want to measure a length AB on this ruler. So let me call this length AB on this ruler. So let's call this space 0. So let us use centimeter scale. Let's use centimeter scale on which only centimeter scales are there. So to measure the length AB. So meaning there is no calibration. It's only the centimeter 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is length AB. So in the picture we can see that length AB is more than 8 centimeter and less than 9 centimeter. You can see that this place from here to here is 8. So but this length is more than 8 and is also less than 9, as you can see. So in this case, least count of this centimeter scale is 1 centimeter because we show only the centimeter scale, no calibration here. So the least count here is 1 centimeter as it can measure accurately up to centimeters only. Now if we note down the length of this line as 8 centimeter, as seen in the picture. Then the maximum uncertainty or maximum possible error in this length can be 1 centimeter, because this scale can measure accurately only up to 1 centimeter. So that means the least count of this ruler is 1 centimeter. So now let's put centimeter marks to do another illustration of least count. Then you can understand better again. So now this is the ruler. Still want to measure the length AB. Let's call this length AB. So this will be 0, 1, 2, 3, 4, 5, 1, 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2. 5. 1, 2, 3, 4, 5. 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4. 1, 2, 3. So let me reduce this length to now. If you look at this kind of scale, so this kind of centimeter scale, I have the centimeter marks here. That is all this calibration. So in the previous one, no centimeter marks here. So if in the picture here, you can see that the length AB now is more than 3.2. That is, this is 3. This is 3.1, 3.2. Look at where it stopped, somewhere here. That means the length AB here is more than 3.2, but less than 3.3, because this is 3.1, 3.2, 3.3. So it is more than 3.2 but less than 3.3, as you can see in this diagram. So if we write down the length of this line, now let's say we write down the length as 3.3 centimeter, though it is more than 3.2 but also less than 3.3. But now if we take it as 3.3, that means this measurement has two significant figures in this way. So in which 3, this 3 here is absolutely correct, while the other 3 is reasonably correct. You can say it's doubtfully correct because it's not, it's a decimal. You can see that it's not up to 3.3, but we only take the measurement as 3.3. So it is only 3 that is correct in this case. The other 0.3 is doubtfully correct. So least count of this scale is 0.1 centimeter, because this scale can measure accurately up to 0.1 centimeter. Maximum uncertainty or maximum possible error in this scale, in this kind of ruler, is 0.1, can be 0.1 centimeter, because this one can measure up to 0.1. That's why this place can be 1 point, 0.1, 0.2, 0.3, 0.4, 0.5. But the previous one I drew, the previous ruler, is only 1, 0, 1, 2. This one no calibration. That means this one can only measure up to 1 centimeter only. Now that is least count. So you can say least count LC in short So least count now, you can define it, you can say it's the smallest measurement that can be measured accurately by an instrument. So, or least count is possible maximum possible error. That is also least count. That means I can also say least count or accuracy. Least count or accuracy in measuring instruments. Least count or accuracy in measuring instruments. We have already discussed accuracy in measuring instruments in first video of measurements. Now what do we say about the accuracy of the measurement? So if you go and check the video, we said the accuracy of a measuring instrument is the highest number of decimal places to which an instrument can measure in terms of a specified unit of measurement. So that means maximum possible error in a measurement is least count. Now in the next video, I will start error analysis in full. So I use this video to explain least count and measurement. So now let's see error analysis in full. Thank you.